Alrighty, we'll go right into the explanation of the project here. Right here you can see the actual PCB board design that we made. For this project, we had to sample current at such a high frequency that we had to create our own current sensor to do it. In the back there, you can actually see kind of the board design and circuit layout, and here is the PCB itself. This is also our prototype board here. We have it connected to an Arduino that works as the data acquisition unit. Here's our custom user interface. Here we made this to allow a plotting of the current waveform data. Essentially what the project actually does is we hit a button here, we run a motor and a gearbox. The system itself begins sampling the data, and it does a mathematical FFT transformation. You pull the data from a CSV file that you just got, and it will plot all of the waveforms there. Why this data is important is it will allow you to diagnose any mechanical failures within the gearbox by the use of a non-invasive sensor. And we're talking about machinery here that if it goes down, it could cost hundreds of thousands of dollars. It could cost downtime. So anything, any machine driven by an electric motor could have a sensor like this installed and have mechanical wear and component damage diagnosed on it. Here I have some of the plots, and I have some of the settings set on our UI, where it calculates what are called gear mesh frequencies, which are parameters based off of the shafts and gears within the gearbox. And you can toggle whatever gear diagnosis you want on and off here. And it plots the line in which that gear fault would occur. And right along here, you can see this is some of the data that we collected. It was a major gear fault that we caused by manually shaving down these gears and switching them out. So we knew exactly what faults would occur. But you can see for this particular bit of data, which was a motor spur gear, that spike, that peak, occurred right where we predicted it to be. Like, seriously, like right on the dot. It's kind of hard to see at that distance, but there's a spike right here where that orange line is. And you basically have like a baseline current, or some baseline data that you'd compare it to. This is what the motor gearbox looks like typically. And you can see that there are no spikes here at all along this peak. But in the damage data, there is a spike. So the custom sensor that we built for this project to sample this fast and data acquisition unit enables us to see and predict failures on this gearbox that you wouldn't normally be able to, and could potentially prevent catastrophic damage of important industrial machines, and ultimately be used as a solution for many other pieces of machinery, not just what we designed it for. It could theoretically be put on all kinds of industrial machinery that is driven by an electrical motor. We're also working to try and put a Clark and Park transform in it at a later date to maybe even try and diagnose issues with the motor itself. But that's fundamentally what it does. A lot of love went into this project. And, well, it works, and it works good.